Okay, now let's finish with the sound. Let me show you how it looks like. Now let's open this project. I added two panels, one for the sound, and second on the top we will put some buttons here in future to open settings form. But now let's talk about the sound. So let's run it. I put here two buttons for speaker and microphone, and here will be a picture spectrum. So let's connect radio. Radio is connected. Now let's start the speaker. So here we can see in CW mode and medium filter, we can see the spectrum, and we can see the waterfall. Let's switch it to different modes, different filters. So now it looks like this. Let me show you how it's working. I created additional audio CPP file, and of course audio H file. Here in H file is listed functions we're using. It's for the sound. Init wave in is the speaker, stop wave in speaker, init wave out is microphone, and stop wave out microphone. The color function is for waterfall, to make it look similar like in ICOM radio. So we are going to use wave format in our project, 8 kilohertz 8 bits format. It's the simplest format, but in case a lot of people using a mobile phone as server for radio, or sometimes socket for radio, with low speed, better to use the lower audio formats. So we are going to use Win API, so we create H-wave in, H-wave outs handles. Buffer size will be 5012 bits. It's called in sound and called samples, because sometimes it's when it's 16 hertz, it have 2 bytes. So let's talk about the samples. Also we need to create headers, buffers. We're going to use 8 buffers, because one buffer is not enough. Sound will be flicking. And let's create logic variables. We needed to safely stop sound. So the first we need to initialize sound. We have to create wave format. Will be wave format PCM, one channel mono, 8 kilohertz, 8 bits per sample. So in bytes per second, 8,000. So 8,000 bytes per second. Then we need to open our microphone and speaker. So we use a wave in open. Wave in open, we open it with callback function. So when we run it, callback functions will be working forever until we stop it. Also we open out, wave out open. It's for our speaker. It's working without callback. Then we need to initialize the headers and buffers for audio in and audio out. So we initialize all 8 buffers. Then we prepare headers, all 8 headers, wave in prepare headers. Then for incoming audio, wave in add buffer. For outgoing audio, we just prepare headers. And in final we run function wave in start. So this function is starting callback function. And this callback function will be playing all 8 buffers one by one. While one buffer is playing, other buffer is filling by incoming data. Here, when buffer is filled, we also run the function show spectrum, and here is post message to the main form to update the picture of the spectrum. And when buffer finished playing, we put break and it's starting again for the new buffer. So when all the 8 buffers playing, we will function restart by itself. Same we did for the microphone. This function is T-color function. It's just for painting our spectrum. So wave in, init wave in is init a microphone, init wave out, init speaker. If we're using ICOM built-in sound card, it doesn't have duplex mode, so we need to use one by one. If we listen the radio, we're not able to use microphone. But if you use an additional sound card instead of ICOM internal one, you can work in full duplex. To stop the audio, we're not able to just stop it. We need to safety stop it. So what we are doing, we are making speaker stop is true, so our callback function no more playing. Then we reset the wave in and wave out, so it will restart all buffers Then we need to sleep 500 milliseconds to wait buffers finished. Then we stop it. These two pictures is a spectrum. To get a spectrum, we need fast Fourier transform. I created additional CPP file for it. I'm not going to explain how it's working because it's just clean mathematics, and not much people understand the formulas. If you're interested in how it's working, you can easily find a lot of information on the Google, but we are just going to use it. We don't need to know how it's working. It's two buttons, switch sound on and off. So if speaker on is false, we initialize it, we run init wave in function, and speaker start working. Also we repaint the red image to the green one, and we start painting. We prepare images for painting the spectrum. When we're going to stop it, we paint our pictures into default color, and then we run the function stop wave in, so it's safely stopping the audio. So let's see. Oh, I forgot. Let's do radio ID. So audio started. So it's on the top is the spectrum, and on the bottom is waterfall of the signal. Our wave format allows us to make a 4 kHz width, but in most cases from radio, signal coming less than 3 kHz bandwidth, so we don't need it. 3 kHz on the spectrum is enough. In microphone, I already included all the functions to run microphone, but I disabled it. Let me show you. So you can easily enable it if you're using external additional sound card, which allow you to work in full duplex. Because I don't want to make any conflicts. To start using this sound program, in sound settings, okay, let me show you. To enable microphone, you just need to delete return in this function. To start using audio in sound settings, you need to set as default microphone is your ICOM sound card or any other card you're going to put microphone, and default output default speaker is your computer sound card. When you switch to the microphone mode, it just reverse it. In future, we will when we will make a big settings form, we will add options to select cards for microphone and audio, but now let's use it as default. So here is card is 0, and microphone card is 0, and speaker card is also 0. In microphone will be 1 and 1. In this program I will enable microphone myself when I will add a transmit button. So in the USB or in AM FM mode it will switch the cards. In CW it will keep it as a speaker. So you can hear callback from radio. Use it as monitor. So with the sound, for now we finished with sound. Of course it requires a little bit more work, but right now we finish with it. We will continue it later. So we are already ready to start with the network connections, but before to make a network, before we did not forget CIV commands. Let's make a small project on STM32 card. Let's make a external CIV control device. I found in my storage STM32F407 card board and display. So next two videos I will show you how to make external CIV controller on STM32. Thank you.